All right, welcome to the Explainer. Today, we're putting on our detective hats and heading out into the cosmic wilderness. Our mission? To track down a suspect that's pretty much impossible to find. A lone planet just drifting in the endless dark between the stars. And that's really the central question here, isn't it? I mean, we're used to finding planets because they're tied to a star. They block its light, they reflect its light. But what do you do when a planet is a cosmic orphan, completely on its own? How do you even begin to look for something like that? Well, these super elusive suspects are what astronomers call rogue planets. But personally, I think of them as cosmic ghosts. They just float silently through the galaxy, totally invisible to most of the ways we have for finding things out there. So, a rogue planet is basically a world without a sun. It got kicked out of its home system somehow, and now it's just left to wander the galaxy all by itself. With no starlight to light it up, seeing one directly is, well, it's nearly impossible. So how on earth did our detectives find one? They used a very, very clever tool, one that was predicted over a century ago. And that tool comes to us from none other than Albert Einstein. See, he predicted this incredible phenomenon that lets us see the invisible, not with light, but with gravity itself. The technical name is gravitational microlensing, but a much better name for it is Einstein's magnifying glass. The core idea is actually pretty simple, but it's totally profound. Einstein figured out that massive objects don't just pull on things. They physically bend and warp the very fabric of space-time around them. The more massive the object, the bigger the warp. And, as we're about to see, this distortion does something amazing to any light that happens to pass through. Okay, so here's how this magnifying glass works in practice. Imagine our rogue planet, that's the lens, drifting right in front of some distant star. As it passes by, its gravity warps the space around it. And this warp acts just like a lens, not just bending the light from that background star, but focusing it and magnifying it, making that star appear to temporarily get brighter from our viewpoint right here on Earth. And one of the researchers, Przemek Mroz, he put it perfectly. He said, "The beauty of microlensing is that it works even if the lensing object emits no light at all." And that right there, that's the absolute key. The object's gravity is doing all the work. It is the perfect tool for hunting down these dark, invisible suspects like rogue planets. So with their method in place, astronomers were busy scanning the skies. And then in 2023, they detected something. This brief, sudden brightening of a star. It was a microlensing event. They gave it the designation OGEL 2023-BLG-0524. And it was weird. The whole thing lasted just 8 hours. That's it. A momentary flash in cosmic terms. This incredibly short duration was the first huge clue that they had found something really, really small. The timing here is absolutely critical. You know, think of it like a shadow. A huge object, like a star, takes days or even weeks to pass in front of the background light, so it creates a long event. But our 8-hour anomaly was unbelievably brief, and that pointed the detectives toward a much, much smaller culprit, something with the mass of a planet. An 8-hour signal was strong evidence for sure, but it wasn't exactly a smoking gun. Was this really a lone rogue planet? Or could it just be a normal planet that's orbiting really, really far from a dim parent star? The investigation was on. So the team got to work, methodically checking things off. They quickly ruled out a close companion star because a nearby star would have made its own longer signal. And there's nothing. But then they had this absolutely brilliant idea. They decided to dig through the old case files, specifically archival data from the Hubble Space Telescope. And this is where the story gets really cool. It turns out, by just pure serendipity, the Hubble telescope had taken a picture of that exact patch of sky way back in 1997. That's more than 2 decades before the microlensing event even happened. This was the lucky break they needed. So using computer models, the astronomers calculated exactly where a potential parent star would have been in that 1997 Hubble image. They looked, and there was nothing there. This was huge. As you can see here, depending on the model they used for the stars in that part of the galaxy, the fact that there was no star in that old photo allowed them to rule out between 25 and nearly 50% of all possible parent stars. Any star that might still be there would have to be incredibly faint, which pushed the rogue planet theory right to the very top of the list.
So the evidence is strong. It all really points to a lone wanderer. But in science, and especially in this kind of cosmic detective work, the case isn't closed until every single possibility is ruled out. And there's still a little bit of ambiguity left.
The ambiguity really boils down to two main scenarios that both fit the data. As we can see here, it could be a Neptune-mass planet that's relatively close to us, in the galaxy's disk. Or it could be a bigger, Saturn-sized planet that's much farther away, out in the dense galactic bulge. For now, both of these possibilities are pretty much equally likely.
So what's the final verdict? Well, while the evidence is pointing overwhelmingly toward a rogue planet, the detectives can't 100% close the case just yet. There's a slim chance it's a planet in a very, very wide orbit around an extremely faint star, one that was just dim enough for both the survey and that old Hubble image to miss.
So what's the final step to close this case for good? We wait. That's right. The foreground planet and the background star are slowly drifting apart from our perspective. In about a decade, they should be far enough apart for our most powerful telescopes to see them as two separate points of light. If we look then and still only see the background star, we'll know for sure that our suspect is a true cosmic ghost.
And that leaves us with this really fascinating final thought. This whole discovery was, in the team's own words, partly serendipity. It was a lucky find connecting a brand new event to data that had just been sitting in an archive for 25 years. It just makes you wonder, how many other cosmic ghosts are out there, waiting patiently in the data for another sharp-eyed detective